Imagine two moons in our solar system, Europa and Enceladus, each with a unique feature that sets them apart from the rest. Europa, with its hidden ocean beneath miles of ice, and Enceladus, boldly displaying its mysteries with its active geysers. These icy moons hold incredible potential, not just for their mystery, but for what's lurking beneath their frozen surfaces. Could these hidden oceans harbor life? Or are they cold, lifeless voids? Today, we'll explore the fascinating worlds of Europa and Enceladus, uncovering the secrets that could change everything we think we know about life beyond Earth. Europa, Jupiter's icy moon. Europa, one of Jupiter's largest moons, might look like a desolate, frozen landscape. But beneath its ice lies something extraordinary. A deep ocean where the conditions for life might exist. This icy crust, crisscrossed with ridges and cracks, hides a dynamic world below that scientists are eager to understand. But how does a liquid ocean survive beneath this frozen shell, where surface temperatures drop to minus 260 degrees Fahrenheit, minus 162 degrees Celsius? The answer lies in Europa's relationship with Jupiter. Europa's orbit is slightly elliptical, causing gravitational stretching in a process known as tidal flexing. This generates heat within Europa's interior, keeping its ocean liquid despite the frigid surface. Europa's ocean is no small pond. It's estimated to be up to 60 miles, 100 kilometers, deep, far deeper than Earth's oceans. Even more exciting, this ocean might contact the rocky mantle below, allowing chemical reactions similar to those around deep-sea hydrothermal vents on Earth. Such environments here on Earth support thriving ecosystems without sunlight. Could something similar exist on Europa? Europa's surface also hints at its potential for life. The cracks and ridges suggest that the ocean interacts with the icy shell above, pushing water upward and reshaping the surface. This activity makes Europa's ice appear much younger than its 4.5 billion year age implies. These dynamics suggest a constantly active environment below, a key condition for life. The chemical composition of Europa's ocean adds to the excitement. Scientists believe it contains salts, minerals, and perhaps even organic compounds, the building blocks of life. If these elements exist, they could facilitate the emergence of life, just as they did in Earth's early oceans. NASA's Galileo spacecraft provided first-hand evidence of Europa's ocean during its mission in the late 1990s. It detected distortions in Europa's magnetic field, consistent with an electrically conductive subsurface layer, likely a salty, liquid ocean. This confirmation made Europa a prime target for future exploration. Now, with the upcoming Europa Clipper mission set to launch in 2024, NASA is preparing to investigate Europa like never before. The spacecraft will perform detailed flybys, studying the thickness of Europa's ice shell, the composition of its subsurface ocean, and the potential presence of water vapor plumes escaping through surface cracks. These plumes could be an accessible window into the moon's hidden ocean, similar to the phenomena on Enceladus. Europa, a storied world, holds secrets about its formation, its ocean's dynamics, and possibly the origins of life itself. If insights from Europa Clipper prove fruitful, the moon could forever change how we view habitability in our solar system and beyond. The potential discovery of life forms different from anything we can imagine would be truly groundbreaking, and with each discovery, the answer seems more possible. Enceladus, Saturn's icy moon, with a secret. If Europa is secretive about its ocean, Enceladus is its polar opposite, boldly displaying its mysteries. This tiny moon, just 310 miles, 500 kilometers, in diameter, is distinctively active, spewing water vapor and organic compounds into space through massive geysers. Enceladus owes its geological activity to its gravitational relationship with Saturn. Like Europa, Enceladus experiences tidal heating, which keeps its subsurface ocean from freezing solid. These forces are especially concentrated at the moon's south pole, where gigantic cracks in the ice, known as tiger stripes, vent geysers of water vapor into space. NASA's Cassini spacecraft flew directly through these plumes, revolutionizing our understanding of Enceladus. The plumes were found to contain water, salts, and organic molecules. Even more astounding, Cassini detected hydrogen gas in the plumes, a sign that hydrothermal vents may exist on the ocean floor, just like those on Earth where life thrives in total darkness. Enceladus's ocean is global, lying beneath about 20 miles, 30 kilometers, of ice. The key detail: its ocean is in direct contact with the rocky core, allowing for water-rock interactions that could fuel life. On Earth, hydrothermal vents release heat and nutrients, enabling ecosystems to flourish at the bottom of the ocean. Similar vents on Enceladus could support alien microbes, or even more complex life forms. Enceladus's geysers make it uniquely accessible for study. Unlike Europa, where drilling miles below the ice might be necessary, Enceladus essentially shoots samples of its ocean directly into space. This accessibility and its strong potential for habitability make it one of the best candidates for finding extraterrestrial life in the solar system. While no missions are planned, ideas like the Enceladus Orbolander propose orbiting and landing on the Moon to sample its surface. Others suggest missions to fly through the geysers and analyze the material for biological markers. Enceladus's accessibility and strong potential for habitability make it one of the best candidates for finding extraterrestrial life in the solar system. This small, icy moon defies expectations at every step. Could life already be thriving in its ocean? Enceladus practically begs us to come back for answers. What might alien life look like? What would life look like if life existed on Europa or Enceladus? Most likely we're talking about microbes, tiny single-celled organisms similar to the ones that dominated Earth's oceans for billions of years before complex life evolved. But even discovering microbial life would be groundbreaking. It would mean life isn't unique to Earth and could be widespread across the cosmos. These potential life forms might survive through chemical energy rather than sunlight, similar to Earth's deep ocean bacteria living near hydrothermal vents. If Europa and Enceladus have similar vents, they could provide the heat and nutrients necessary for life to thrive in total darkness. But could anything more complex exist? Maybe. Europa's ocean, for example, has likely been stable for billions of years, potentially providing enough time for evolution to create multicellular organisms like tiny jellyfish or shrimp-like creatures. Likewise, pockets of liquid water within the Moon's icy crusts could host life, much like glaciers on Earth that harbor microbes in tiny water pockets. The challenge lies in detecting life beneath miles of ice. Europa's ice may leak ocean material onto the surface, and Enceladus's plumes provide direct access to its ocean. By analyzing these materials, future missions could identify biological signatures, chemical markers, or microscopic organisms. Still, it's important to keep our expectations realistic. The oceans of Europa and Enceladus could be sterile, lacking the right conditions for life. Even so, understanding why these oceans are uninhabitable would teach us valuable lessons about the limits of life in the universe. From icy surfaces to subsurface oceans teeming with potential, Europa and Enceladus represent some of the most exciting frontiers in the search for extraterrestrial life. With every new discovery, we draw closer to answering one of humanity's biggest questions. Are we alone? The mystery of these hidden oceans isn't just about what lies beneath the ice. It's about the fundamental nature of life itself. Whether we find thriving ecosystems or barren waters, the search will redefine our place in the cosmos. And maybe, just maybe, these alien oceans will hold the key to understanding life far beyond Earth.